We move to the last question in the writing part, question number 20. It is about trigonometric substitution. And I have clearly mentioned it's x equals a sine y. This y is just a variable, it can be anything. You can take it as sine theta as well, that's fine. But they have told you this formula, so we can just focus on this formula only. Now we need to recall a few of the trigonometric formulas. The Pythagorean identity, that is sine square x plus cos square x equals 1. This is important. And then we can derive the other ones. And there is secant square minus tan square x equals 1. And then you can easily derive the others. Similarly, over here, we have cosecant square x minus cot square x. Remember only the first part here, first one. You can rearrange them. This is by just moving cos square to the other side or sine square to the other side. You will get the other two. Because they have already mentioned it's x equal a sine y, just stick to one, that is more than enough. And double angle identities are not required for this particular topic, but in general, if you remember them, in case for simplification, if you need, we can use them up. And there are trigonometric integration identities. Obviously, we are dealing with, trigonometric substitution. So you need to know the basic trigonometric integration formulas. And they are simple. Now over here, if you can see a pattern. Whenever there is c cosine over here, see cotangent, c involved, co something, cosecant or cotangent, cosine over here, they will have negative signs. Okay, whereas it doesn't matter you're integrating sine or cos. The answer, if it is c, it will have negative. So please remember this, because over here you're integrating sine, you're getting minus cos. Don't think, okay, for secant you should have minus. No, for cosecant you should have minus, because what's the answer? If the answer is having co, then it's a minus sign. Over here, natural logarithm cos x, right? So you have a minus sign. Now we will look into the formulas. These are the actual formulas, but you're so lucky that you have to deal only with one. That is, your problems will be in terms of a squared, that is a constant, minus x squared. Now that will be the substitution which you'll be using is x equals a sine theta. This can be y as well, don't worry. Now here, since there is square root and square, the intervals are mentioned, but you don't need to worry about that much. This formula is important. 1 minus sine square equals cos square theta. Now let's solve this up. Here, first thing, you need to see how the form is given. Now, since they have given only one type of problem, no matter what, your question must be in terms of a squared minus x squared. So now you have other terms, that's fine. Now, how would you write this constant as a squared? You can write that as x squared root of 4. Square root of 4 is 2, so you can write 2 squared minus x squared. So this is how we get it. Now, you know a value is what? 2. So how can we write x now? We have been told we have to use this particular substitution. We can't go with anything else. We have to take a sine theta. That is the formula over here. Now you might be thinking, why we complicated so much? Why can't we directly solve it? I mean, some problems will be possible to solve with direct substitution if you strategically take the substitutions, Now, say, for example, this was x outside, then yes, you can try with, taking this term as something, and then yes. But now, otherwise, say this problem, it's not possible to solve other ways. This is the only way. So mathematicians had tried a lot of different methods, and then they came with, this a sine theta substitution and solving such cases. Now here, if x is a sine theta, what happens over here? A is 2 sine theta. So this is what we have to substitute. But we will substitute x fine, then the constants. But what about this dx? Now we don't have x anywhere. So we have to derive it. Dx would be dx with respect to theta, right? Because right side is theta. It will be 2. What is the differentiation of sine? 2 is a constant. Differentiation of sine is cosine theta. That's it. Now let's take this theta to the other side because we want only dx. Dx is equal to 2 cos theta d theta. Now we have dx and we have x. Let's substitute it back. So we will have to evaluate 1 by 2 sine theta the whole square, that is this x square, square root 4 minus again 2 sine theta the whole square. What is dx? 2 cos theta d theta. This is it. Now, how can we go further? First of all, let's simplify how much we can. Say, multiply this power inside and what we can do, how much we can, let's simplify it. So what I'll do is this, instead of writing it outside this fraction, I'll write it in the numerator because it's up only, right? Instead of 1, I'll write 2 cos theta d theta divided by 2 multiplied by sine theta. So the square is for both the terms. 2 square is 4 and we will have sine square theta. And what about this? Here we will have 4 minus, again it will be 4 sine square theta. Now what happened to this 2? I squared it. 2 square is 4, sine square is theta. Now we don't take the whole square because this is not plus or minus, it is just 2 multiplied by sine theta. So when it's ab the whole square, that is a square b squared. Okay. Now if it was a plus b or a minus b the whole square, then we have to use the identities like 2ab plus b square and so on. But for now, it's just multiplication. So just square both the terms and we get it. Next, what do we do? Here, this is done. I mean, we just simplified. Nothing is done. You know, we are just rearranging it. See now, given question and this is equal. Why? Because we have assumed x to be so and so, dx we found out from this x, and we have just substituted. We have just manipulated the given question. That's all. Now let's try and solve something more, like if we can. Now over here, integral, let this 2 cos theta d theta be there. Over here, let's leave that. Okay, we can cancel this 2 and 4. We will do it in the next step. Sine square theta. Now here you can see there is 4 and 4 and there is a minus. If there is minus or plus, you can remove that 4 common out. Everything is inside the square root. When I remove that 4, what happens is over here 4 is gone, 1 minus this 4 is gone, only sine square theta is remaining. So look here, if I multiply this 4 inside, I'm going to get 4 times 1 is 4, 4 times sine square theta is 4 sine square theta. It's the same thing, I've done nothing wrong. Now here, if I have square root and 2 terms multiplied, I can split the square root. It's square root 4 and square root 1 minus sine square theta. So over here, wait, 2 times 1 and 2, right? So what we have is cos theta d theta divided by here sine square theta. And this square root 4, if I bring this 4 outside, it's going to be 2. Why? Okay, I should have written 2 over here as well. This 2 is remaining 2 and another 2. Why? Because I've brought the square root 4 outside. It's 2 and then I have square root 1 minus sine square theta. Next, what I can see is 1 minus sine square theta. Now I know from Pythagorean trigonometric identity, it is cos square theta plus sine square theta equals 1. If I take the sine square to the other side, it's going to be 1 minus sine square theta, that is cos square theta. So integral cos theta d theta divided by 2 times 2. There was 2 over here. 2 by 4 is 1 by 2. That is in denominator 2. And 2 will be 4 sine square theta. And then what do we have? Square root, but 1 minus sine square theta is cos square theta. And now this square root and square can be cancelled off. So this is going to be cos theta d theta divided by 4 sine square theta into cos theta. Why? Because the square is gone. Now this cos theta cancels and I'm just remaining with 1 by 4 sine square theta d theta. Now do you know what is this formula? How can we solve this? But before that, I'll just clear this out over here. Now we have 1 by sine square theta and there is no integral formula for 1 by sine square. But you know what is 1 by sine square? It is cosecant, right? So I will take the constant out, 1 by 4th, I'll remove it out, integral. Instead of 1 by sine square, I'm going to write cosecant square theta d theta. Now, does anyone recall any formula here? It's 1/4 integral of cosecant square is minus cot theta. So this is the answer. If we solve this given question, we are supposed to get this answer. But you might be thinking, okay, here we had x. Now there is nowhere x to be found out. What if you have to substitute some value of x or anything? We know that x is 2 sine theta, isn't it? So what is sine theta exactly? Sine theta equals x divided by 2. I just divide both the sides by 2. You get this over here. Now what information does this give? Now don't take theta. If you substitute theta, it'll be in terms of sine inverse. It's more complicated. Though it's correct, it's better to do this. You know the unit circle method. Over here, imagine this is theta. We know sine is always opposite by hypotenuse. So opposite side for theta over here is x. Hypotenuse is 2. So what is this adjacent? Adjacent would be basically using Pythagoras theorem formula. This is 90, right? This is adjacent. That will be square root 2 square minus x squared. How did I do this? Because we know, imagine this is unknown. I'll write it as a adjacent adj. So adj square plus the other two sides, this x square will be equal to what? 2 square. Why? Because it is the hypotenuse. That's the Pythagoras theorem. A square plus b square equals c square. Now I need what? Adjacent square. So I will take this x square to the other side. It will be adjacent only I need. It's squared, right? Will be equal to 2 square minus x square. Now take the square root on both the sides. You're going to get adjacent side equals 2 square minus x square. So another easy way to write is, if any of this side is unknown, that side will be equal to square root of the hypotenuse square minus any one known side. So that is 4 minus x squared. So this is the adjacent, that's cos, right? Adjacent. Now from this we can find many things. We can find cosine, we can find tangent, we can find sine. Sine is already known, but the other two now can be found out because we know all opposite, adjacent, and hypotenuse. Now what is given over here? We have cot theta, that is cotangent. So let us find the tangent over here. Tangent, you can directly find cotangent, but you know tangent formula is something that you will all generally remember. It is opposite by adjacent. Opposite by adjacent, right? So no hypotenuse over here. So opposite side is over here x divided by square root of 4 minus x squared. So now this is tan. But what is cotangent? It's the inverse of this. Cotangent cot theta equals square root of 4 minus x squared by x. So now technically over here, whatever the answer we got, right? We know what is the cotangent value, isn't it? Now this was like this. I'll just rearrange this and write the answer is supposed to be minus 1/4 cotangent theta. We can leave that as the answer. It's a writing, so generally you will get a lot of marks, but if you're aiming for the full top marks, it's better to convert this and now write over here minus 1/4 square root 4 plus, it's minus x squared divided by x. Now when we write this up, it will be minus square root 4 minus x squared by 4x. This is the final answer. I hope this is clear. So the integral of this would be over here. This is the final answer. So that's what we get. And let's check the answer. It was negative 1/4 cot theta, but in terms of x, this is root of 4 minus x squared by 4x and so on. So you can see over here, we take 2 sine theta and we derive it. And what did we get when we derived? We got it as 2 cos theta. It's very important. It's positive cos. Don't get confused with integration. And then d theta over here, and we substituted everything back. See, the question became like this. And then what we do is we try simplifying, rearranging. Finally, we got this answer, negative 1/4 cot theta plus c. Okay, now I forgot to write one important thing, guys. Over here, the final answer should have plus c. Why? Because we did integration. So we don't need to write anywhere before. When we finally use this integration over here, see, this would have plus c. I just remembered that. Please don't make that same mistake in your exam. Remember to write plus c. But I just realized that they have stopped it over there. But it's good to convert it back to x, okay? Because I think over here they're all converted back to x. Yes, you can see over here they're converted back to x. Now let us solve one more problem. I won't do this one because this is just like what we did just a while ago. Let me do another different one. Okay, almost all are the same ones. Okay, let me do this anyways. But over here there is x cube on the top. So let's try this out. So looking at this, you know it is only one formula for you. So it resembles a squared minus x squared, the square root of that. So we will rearrange this. 9 can be written as 3 squared minus x squared. And what do? We need to assume x is a sine theta, right? So what is a? 3 sine theta. This is done. And now what is derivation? Dx will be, I'll directly write it. It'll be 3 cos theta, and d theta will be over here. I just written it directly. Now let's substitute everything back. It'll be integral of x squared will be a, I'll not write a, I'll write 3 cube, and we have sine cube theta. I did not write whole cube. I just split the cubes directly. And over here we have 9 minus, what is over here? It is again 9, because it's 3 squared is 9 sine square theta. And what is dx? Dx is 3 cos theta d theta. Now let's rearrange and write how much we can. Over here it will be 9 3s are 27. 27 times 3 is 81. So I'll write it all together. Okay, integral, I've multiplied all of them, it will be 81. And over here we have sine cube theta cos theta d theta in the numerator. What is there over here? We can remove this 9 common, and I'll remove it out of the square root. So it's going to be 3 outside over here. And we will remain with 1 minus sine square theta. This is again 27, back to 27, and this 3 cancels off. We will have sine cube, wait, I'll do the other things later, cos theta d theta divided by, what is up over here? This one will be cos square theta, square root of cos square theta, and then this will be cos theta itself. Why? Because square, right? It's gonna be cos. So I'll just cancel this entirely. The square root and square root cancels, you're remaining with cos theta. This is gone. This cancels off, and then what are we remaining with? It's only sine cube theta. But oh, I just remembered this 27 I have not written out over here. So it's 27. That's the constant, so I can remove it out. Sine cube theta d theta. Is there any formula to solve sine cube theta, integral of sine cube theta? No. But there is a formula for sine cube theta. I'll write it out over here. So sine cube theta, that is equal to, there's no space over there, it's 3/4 of sine theta itself. Okay, it can be sine cube x, then it will be sine x, 3/4 sine x. You should subtract it with 1/4. It's like a, what I remember in my mind is this is a whole, right? 1 with 3/4 sine theta, 1/4 will be sine 3 theta. So this is the formula. So now I will just rearrange and write this out. It's just, this is what we had assumed. We do not need that anymore. We needed to put it back to x, but it's a simple thing to remember. Here, it is 27 integral. Instead of sine cube theta, I'll write 3/4 sine theta minus 1/4 sine 3 theta. Is that okay? And what do we have out? D theta. Now we can integrate this. Why? Because there is minus, so we can integrate this individually, isn't it? This is all together. Now this was a single term over here, but we used the formula of sine cube theta and got this. How would you solve this now? See, here you can take 4/4, 1/4, 1/4 outside. So I'll just take that. It'll make it easier, you know. So I will take 27 divided by 4, because this 4 is a constant altogether. I've taken from both and written over here. And integral, what is there? 3 sine theta. Now over here I can't remove 3 because 3 is not there in both. Sine 3 theta is not same as 3 sine theta, okay? So I'll write this minus integral of 1/4 is gone out, right? So I'll have only sine 3 theta. Now both should have d thetas, d theta, because I'm splitting this and this. See this in the bracket, right? Distributive property, integral and d theta for this term and for this term. Over here it'll be minus. And now what we can do is we can just solve them up. Here, first one is pretty simple. What is the formula? It will be over here 3 minus 3 cosine theta. Then plus c, we will write it together at the end because there are two terms. Okay, this is the first term. Straightforward, there's no problem over here. But this one, what happens is it will be 1 by 3 because it's in terms of sine a theta. What is the formula? It is 1 by a sine, sorry, it's cosine now, cosine a theta and minus sine, the formula for sine a theta. So we have sine 3 theta, so it will be 1 by 3 cosine 3 theta, and this minus is multiplied over here. So what happens is minus and minus becomes plus. Okay, this is the answer, plus c. Now I'll just multiply this inside. It's gonna be, you have to just put in the calculator and solve it, but 27 3 times is 81. So 81 minus 81 by 4 cos theta plus, over here what happens is 3 1 times and 3 9 times, so it will be 9/4 cos 3 theta plus c. So this is your final answer. Now here we have everything in terms of theta. What if we want in terms of x? Then I hope you remember we just now did this. X is equal to what? 3 sine theta is what we had considered. So sine theta equals x by 3. See, now over here, generally, since you have 3 theta, you can find cos theta for this, but since there is 3 theta, it's safer to just find theta value. So generally, they just find theta is equal to sine inverse of x by 3. So over here, this would be, you can, 1 minute, let me just look into the final answer. So they have removed this out itself. They're not multiplied it inside, but we have multiplied it. It's fine. You can follow whichever, This is also absolutely right. No problem at all. Or this is also absolutely right. Now I'll stick to what I've done over here. Cos into sine inverse of x by 3 plus 9/4 cos 3 times 3 theta, right? Sine inverse of x by 3 plus c. So this is the final answer. Let us just look into the answer over here. It looks very weird, but over here they have, see that 27 by 4 is outside. Then we have minus 3 cos. What is theta? Now you can just focus on, see this part, Over here they have left it out over here. They have not multiplied it inside. That's fine. I've just multiplied it inside. Now what is theta? Is sine inverse x by 3. You can see. Same thing over here, cos. Over here, they have missed out. See, this is 3 theta. You just can't divide it. Don't think, okay, 3 and this cancels. No, there must be 3 times sine inverse. So please mind this error over here in this question. Everything is right, only the 3 is missing, okay, in the solution. Now, this is correct. Over here, this one, absolutely right. They have forgotten this 3. Now, theta would be sine inverse x by 3. So this, or over here only in this step, you can substitute what theta is. Over here, you can substitute theta in terms of x, and that's enough. So this is how we solve these problems. Please do practice each problem by yourself. The method is same, assuming x is equal to 3 sine theta. No matter which problem comes for the 20th question in writing, it's the same thing. So you don't have to worry. Directly assume that. And then it's like a puzzle. You start putting in pieces over here like Lego, substituting stuff, simplifying, and trying to get the final answer. That's the end of all the writing part. I hope this has been helpful. I wish you all the best, guys. Please do practice more problems and write and study. Don't just watch it. When you're watching the video, please try practice writing. Before I finish off, I just want to thank each and every one of you who have subscribed to my channel, who have liked my videos, who watch my videos. It really means a lot. It's nearing 7,000 subscribers. It's nearly 7,000 now, 50 more to go. I really am amazed by the support and love I receive from all the students. Thank you so much. And I will try my best to do all the explanation videos as soon as possible. Please do stay tuned.